Volume of Brillouin zone. Show that the volume of the first Brillouin zone is 2 pi cube over Vc, where Vc is the volume of a crystal primitive cell. Hint, the volume of a Brillouin zone is equal to the volume of the primitive parallel piped in Fourier space. And recall the vector identity C cross A crossed with A cross B is C dot A cross B A. Okay, so first of all, I want to remember how to calculate the volume of a parallel piped. So let's start with defining the primitive translation vectors. Let A, vector B, and vector C be the primitive translation vectors in the direct lattice Okay, now knowing that we have these primitive translation vectors, how do we calculate the volume of the primitive cell? Then the volume of the crystal primitive cell is the volume of the parallel piped which is defined by these vectors A, B, and C. Okay, now what we do is we're going to form cyclic permutations between vector A, vector B, and vector C. So cyclic permutations, and this is the positive direction, which is the clockwise direction. The volume of the primitive cell is A dot product with B cross C. So we start with A and then we go to B and C. If you start with B, it's B dot product with C cross A. If you start with C, then it is C dot product with A cross B. So that's how we calculate the volume of this parallel piped. Now we're going to go to Fourier space, the reciprocal space. Then we have to find the reciprocal primitive translation vectors. For the reciprocal lattice primitive translation vectors, these are the capital A vector, which is 2 pi multiplied with B cross C. Again, we're using the cyclic permutations. B cross C divided by A dot B cross C, which is 2 pi divided by the volume of the primitive cell Vc B cross C. That is vector capital A, the first primitive translation vector in the reciprocal lattice. Capital B is similarly following cyclic permutations. Now B cross C, I will do C cross A. C cross A divided by B dot C cross A, which is 2 pi divided by volume of the primitive cell, VC, C cross A. And how do I find the third primitive translation vector, capital C? This will be 2 pi. And following the cyclic permutations, after C cross A comes A cross B. So 2 pi A cross B divided by C dot A cross B. And this is going to be 2 pi divided by the volume of the primitive cell, VC, A cross B. Now, what I want to know is the volume of the first Brillouin zone. The volume of the first Brillouin zone, which is the Wigner-Seitz primitive cell in the reciprocal space, the first Brillouin zone. This is basically, again, the volume of the parallel piped which is defined by the new primitive vectors in the reciprocal space A, capital B, and capital C. And how do I calculate this volume? The volume of the first Brillouin zone will be, again, following cyclic permutations. I can choose out of 3 options. The first possibility is capital A dot B cross C. So I form capital A, capital B, capital C cyclic permutations, or it is B dot C cross A, or it is C dot A cross B. So there are 3 different ways I can write this. And if I follow the first one, A dot B cross C, it is vector A. Vector A is 2 pi divided by the volume of the primitive cell VC, B cross C, that is vector capital A, dot product with B cross C, so there are 2 pi VC's twice, so it's going to be 2 pi square over VC square. Then I have C cross A cross with A cross B. And because I have encountered 2 pi over VC 3 times now, this is 2 pi divided by VC parentheses cube. The dot product B cross C dotted with this vector C cross A cross with A cross B. So this is our task. Now, it is given in the problem that there is a vector identity for C cross A cross A cross B, but let's remember where this identity comes from. So I'm going to work on that a little bit. So what is this vector identity? Vector identity for C cross A crossed with A cross B. So this is what I want to know. What is this? And if you take the ith component of this vector, C cross A, the first vector, crossed with A cross B, Now we're using vector algebra, vector calculus. This is epsilon ijk Levisivita symbol, the jth component of the first vector, C cross A jth component, and A cross B kth component. And if I use this once again, the definition of the cross product using Levisivita symbol, this is epsilon ijk. For the jth component of C cross A, I can write epsilon JLM CL AM, and I have the kth component of A cross B. Now, what is epsilon ijk, epsilon JLM? Now, what I do is I form cyclic permutations of ijk. This is the positive direction. And I know that the property of the Levisivita symbol, Levisivita identity, is that epsilon ijk is equal to epsilon jki is equal to epsilon kij. Again, using cyclic permutations. So that's one. And using this property, I can write epsilon ijk as epsilon jki. So this is epsilon jki, epsilon jlm, cl am, mth component, A cross B's kth component. Now I have encountered the product of two epsilons where the j is in the same location, the index j is in the same location. Now I use the following property, epsilon jki, epsilon jlm is Kronecker delta. What I do is I take the product of the first indices here, delta KL firsts and seconds, then I take the product of I and M, then I use I and M, delta I M, not the product, and minus inners and outers. So for this one I will use K and L, those are the inners, and outers are I and M. So this is going to be delta KL so that's going to be delta IJ, sorry. Let's undo this, because I'm going to use the inners, firsts, seconds, and inners, IL. So these are the inners and outers, KM. Delta IL and delta KM. So this is our Levisivita identity that we're going to use. Okay, so for epsilon jki, epsilon jlm, I'm going to write delta kl, delta im, minus delta il, delta km, firsts, seconds, inners, and outers. And then I have CL, AM, and kth component of A cross B. Now, delta KL means that K is equal to L. So, and delta IM means M is equal to I. So, I'm going to substitute CK, L is equal to K, and I is equal to M. So, CK AI. And then I have the cross product A cross B, kth component, and minus, then L is equal to I, delta IL, CI, K is equal to M, so it's AK, A cross B, kth component. So if you write this not in terms of components as a vector, so this is basically telling us that this C cross A cross with A cross B is equal to the vector A multiplied by C dot A cross B minus vector C multiplied by A dot A cross B. Because we have the same components that are being added up, AK and A cross B is kth component, so this is going to give us the dot product. Well, if you take the dot product of A with A cross B, because A cross B is perpendicular to A and B simultaneously, this dot product will give you a 0, and therefore we find this vector identity that C cross A cross A cross B is vector A C dot A cross B. Okay, so now that we have proven the result that was suggested by the problem, the volume of the first Brillouin zone, BBZ1, will be 2 pi parentheses cube divided by VC cube. So I go back. It is B cross C dot product with something. So it's going to be B cross C dot product with C cross A cross A cross B. And that is equal to A vector A C dot A cross B. And what was C dot A cross B? C dot A cross B is the volume of the primitive cell, VC. So for this one, I substitute VC. Therefore, I'm going to have 2 pi cube over VC cube. B cross C dot A, VC times A dot B cross C. What is A dot B cross C? A dot B cross C is the volume of the primitive cell, VC, so this is also VC. So this will be equal to 2 pi cube divided by VC cube multiplied with VC square. So therefore we find that the Brillouin zone, first Brillouin zone, volume is 2 pi cube divided by the volume of the primitive cell, VC. All right, so now to summarize, first we look at the direct space. We have the primitive translation vectors in direct space ABC. The volume of the parallel pipe that's defined by these primitive vectors is the volume of the primitive cell. It is A dot B cross C, B dot C cross A, or C dot A cross B using cyclic permutations. Then we go to reciprocal space. We look at our reciprocal vectors, 2 pi over VC, B cross C, C cross A, and A cross B. These are capital A, B, C. Reciprocal space primitive translation vectors. We find the volume of the parallel pipes that is defined by these primitive translation vectors A, B, and C. That will be the volume of the first Brillouin zone. And it is capital A dot B cross C, B dot C cross A, or C dot A cross B. And we see that this is 2 pi over VC parentheses cubed B cross C dotted with C cross A cross A cross B. And then we look for the identity C cross A cross A cross B by taking the ith component. This is epsilon ijk. The first vector is jth component, second vector is kth component. Then for C cross A's jth component, I can write epsilon JLM, CLAM, A cross B's kth component. Epsilon ijk, epsilon JLM, I rearrange the indices in epsilon ijk to be epsilon jki, again using cyclic permutations. Ijk, jki, and kij are equivalent in the Levisivita identity. So it's epsilon jki, epsilon jlm, clam, a cross b scale component. And for epsilon jki, epsilon jlm, I use the expansion in terms of Kronecker delta. It is delta KL delta IM, firsts, seconds, minus inners, IL, outers, KM. So delta KL delta IM minus delta IL delta KM is what I substitute for epsilon JKI epsilon JLM. And to use this identity, note that one of the indices should be in the same location. And then I have CLAM A cross B scale component. So this Kronecker delta tells me K must be equal to L. So CL will become CK, M must be equal to I, AM becomes AI, A cross B scale component, minus L must be equal to I, CI, M must be equal to K, AK, A cross B scale component. And this is basically telling me that I'm taking the dot product of vector C with A cross B because I'm adding there the same projections, the kth components, and there's the vector A minus vector C, ith component of C, the dot product of A with A cross B. Dot product of A with A cross B is 0 because by definition of cross product, A cross B is a vector that is simultaneously perpendicular to A and B. And so that shows me that this vector is vector A, C dot A cross B. By substituting this into the first Brillouin zone volume, I find that I encounter VC twice in this calculation. So I obtain a VC square that cancels VC cube. So the volume of the first Brillouin zone is then found to be 2 pi parentheses cube divided by VC.